Hello, this is Ms. Dabnick, and I'm here to do an introduction to algebra tiles. So this is going to be very crucial for our algebra unit. Here we have algebra tiles, and we are going to figure out what they're called and how to use them. So these are all on the positive side. Yellow, green, and blue mean that they're positive. You'll also see that these are double-sided, meaning that the red means they'll be negative. Sometimes you will see, instead of yellow, green to show that it's positive. And then here you might see a green tile instead of the blue to show that it's positive. We don't want to call these little square, rectangle, and big square. There are algebraic ways to figure out what these pieces are actually called. And we're going to start with this piece right here. To know the area of this square, meaning the inside of this piece, we have to do base times height, because area equals base times height. Well, we can say that this is 1 unit, and this is 1 unit as well. We have 1 unit length here, 1 unit length here. So when you do base times height, you get 1 times 1, meaning that the area of this little square is 1. We will no longer call this a little square. We are going to call it by its formal name, the 1 piece. Now this is a positive 1, and if you see it on the red side, that means it's a negative 1 piece. Moving along to the rectangle, we want to find out its formal name. So we want to find it, the name of it, by getting the area. Again, the formula is area equals base times height, and if I line up my 1 piece, I see that my base is actually 1 unit in length. And if I want to find out this height, I can try to line up these tiles right here, but you're going to notice that they don't line up perfectly. We end up having a little left over here, meaning we don't know exactly what the height is. So we're just going to call this x. We're not sure, and it's just better to call this a variable standing for an unknown. So the base is 1, the height is x. When you do 1 times anything, you always get that same number or variable back, meaning that we can just say that this is x, and therefore this is called the next piece. Now when you have this big square right here, you can do the same thing we did here and try to line up the sides of the rectangles, and you'll see that they match up perfectly. So that means this length right here is actually x, and so is this length right here. So when I do area equals base times height, I can just say that my base is x, my height is x, therefore my area is x to the 2nd power. We will no longer call this the x, the big square. We'll call this an x squared piece. Do not forget that if it's a negative, then you would just write a negative x squared here, just like you would here. If this is red, that means it's a negative x, and if this is red, it's a negative 1. All right, so what if I give you a polynomial or an algebraic expression and ask you to draw the tiles? For example, if I gave you x squared minus 3x plus 2, the first thing we should notice is that this is positive, so I can just draw a regular unshaded. Unshaded usually means that's positive. And then if I want to show that these are 3 negative x's, which they are, if I just change my subtraction to addition, instead of bringing out your colored pencils, you can just shade in the tiles to show that they will be negative. And then I have 2 positives. All right, one more example. What if I have negative x squared plus 2x minus 4. Well, this is a negative x squared, so I have to draw a big square and shade it in to show that it's negative. I don't want to bring out my colored pencils. I have 2 positive x's, or 2 rectangles, and then I also have 4 negatives when I change the subtraction to addition, so I can just draw 4 little 1 pieces and make sure I shade them in. All right, this is the end of part 1, Introduction to Algebra Tiles. Stay tuned for part 2.